10.4 Inscribed angles and polygons. How are inscribed angles related to their intercepted arcs? How are the angles of an inscribed quad related to each other? Let's start with a new vocabulary word, inscribed angle. And here's an inscribed angle. It is formed by two chords. And notice that, and very important, the vertex is actually on the circle. Now, this is in contrast to central angle, where the vertex is the center, at the center. So you can see the difference between inscribed and central angle. Now, the arc right here that's inside the angle is called the intercepted arc, and the chord that's inside the angle is called, the chord is said to subtend the angle. And all this means is that it's inside. Okay, let's go ahead and notice, I'm going to go ahead and draw the central angle. And I want you to notice that the central angle is pretty wide compared to this angle right here. And so what they're saying is that this angle is actually 1/2 the measure of the intercepted arc. Remember, the intercepted arc is this thing right here. And it's actually equal to the central angle. So this angle and this arc are in a 2-to-1 ratio, because this is going to be twice as big in degrees as this. Let's go ahead and look at the proof. Now the proof has 3 cases, and we're only going to look at one case. The case where the inscribed angle is made by a diameter and by a chord. Diameter and a chord. And what we're going to do is we're going to create another radius so that we create an isosceles triangle. So I know that this is congruent to this, and if this is x degrees, certainly this is x degrees as well. Now, from last semester, we learned that an exterior angle, this is an exterior angle, is equal to the sum of the non-adjacent angles. So this is going to be 2x degrees. So this is 2x degrees. Now, that tells us that this measure right here is the same as the central angle, which is 2x degrees. And the inscribed angle is x. So 2x degrees compared to x degrees is going to be in a 2-to-1 ratio. So this measure is going to be twice as big as this. Or you can say the angle is half the intercepted arc. And that's what it's saying right here. This is half the intercepted arc. Okay, let's go ahead and use that. We want to find angle T. That's this angle right here. Now, remember that this is the central angle. If this is 48, this is 48. And this angle is going to be half of the central angle, or half of this. So this will be 24 degrees. So look at the relationship between central angle and inscribed angle. So this answer is 24 degrees. Now we'd like to figure out this measure right here. But to do that, I think I'm going to try to find this arc right here. And this inscribed angle is 50 degrees. And remember, there's a 2-to-1 relationship. So this is going to be 100. This is going to be half this, or this is twice this. Now I see a diameter, which means all of this adds up to 180. And that means that must be 80 degrees. So this will be 80 degrees. Okay, let's take a look at RS. Now this is an inscribed angle, so that makes this 62 degrees. Now let's take a look at angle T right here. Now angle T is an inscribed angle and it intercepts 62 degrees, so that forces this to be 31 degrees. So what did we notice? Well, we noticed that these two are congruent. Kind of makes sense. They are sharing the same arc. Therefore, the formula, 1/2 the intercepted arc, is going to give them the same results. And that's what this theorem says. This theorem says if two angles intercept the same arc, then these two angles must be congruent. And here's the proof. So we have these two angles, and they're intercepting AC, so they're going to have the same formula, and by the transitive property, we're going to be able to say these two angles are equal in measure. All right, let's go ahead and start. We know that this is 75 degrees, and we also know that it intercepts this arc right here. Now, this angle, angle F, also intercepts this arc, so that tells us that they're going to have the same measure. So this will be 75 degrees. Okay, your turn. Go ahead and try to find the measure of the red arc or the red angle. Stop the screencast. And here are the answers. Now, some of you may not have to show every single step like I did. If you can just give me the end result, 45 degrees, 76 degrees, and 72, you're doing fine. Okay, the next vocabulary word is inscribed polygon. And an inscribed polygon has all its vertices on the circle. And we call this circle a circumscribed circle because it's going around. And we've had this word circumscribed circle for triangles. In the other semester, we were working with circumscribed circles as well. But this is a polygon, not just a triangle. Okay, now let's take a look at this triangle that's inscribed in the circle. And one of the sides happens to be the diameter, so that the hypotenuse is the diameter. That means this is the inscribed angle, this is the intercepted arc. Intercepted arc is 180. We're going to take half of 180 and we're going to get this to be 90 degrees. So whenever one of the sides of an inscribed triangle is a hypotenuse, you know you're going to have a right angle here. Our next theorem talks about inscribed quad. What we're going to try to prove is we're going to try to prove that this angle and this angle are supplementary to each other. We're going to try to prove that they're supplementary. That's this one right here, that they add up to 180. And these will also be supplementary too. So here's the proof. Okay, so this arc right here and this arc right here, the green arc and the red arc, add up to 360 degrees. That's the whole circle. Now, angle F, that's this angle right up here, is going to be half of this green arc. So I tried to keep it color-coded. I'm going to multiply both sides by 2. And so the green arc measure is equal to 2 times the measure of angle F. Now I'm going to work with angle D. And angle D is going to be half the red arc. And to get rid of the half, I'm going to multiply both sides by 2. And I'm going to get a relationship for this red arc. I'm going to take the red arc plus the green arc, and I'm going to, the red arc, remember, is 2, red arc is 2 times the measure of angle D right here, and the green arc is 2 times the measure of angle F. I know these two arcs add up to 360 degrees. If I divide everything through by 2, I'm going to get 180. So these two angles have to add up to 180. All right, let's go ahead and use these two new theorems. Now I see a hypotenuse. So I know that this arc is 180 degrees. So therefore, 2x, this inscribed angle, is going to be equal to 90. It's equal to half the intercepted arc, so therefore x will be equal to 45 degrees, or just 45. This is our other theorem. These two opposite angles are going to be supplementary. So that's going to equal 180, and z plus 80 is going to equal to 180. So y will be equal to 60, and z will be equal to 100. All right, your turn. All right, then let's go ahead and find the answers. X will be equal to 90, and that's because it's intercepting a semicircle, and Y will be equal to 50. And these three angles will add up to 180. These two angles are supplementary, so Y will have to be 112. 112 and 68 will add up to 180, and X will be equal to 98, because 98 and 82 will add up to 180. In this one, we're going to have to set 8x plus 10x have to equal 180. This is 18x is equal to 180, and x is equal to 10. These two, c plus 2c minus 6, have to equal 180. So this is 3c equal to 186. So c is equal to 62. And let's go on to the next page. Tomorrow in class, we're going to be taking a look at constructing a square inscribed in a circle.